Okay, the last question that you've got in your booklet related to BGS maps is this one here from the Clitheroe map. I've given you a very, very small section related to this particular question from the map itself, and I've also given you the relevant bit of the general vertical column. So this section here is taken from this part of the geological map, and I'm going to use this map to sort of go through some of the ideas on that particular question. As I mentioned, the scale is at the top. 1 centimetre of the map is equivalent to 25,000 centimetres on the ground, or as I said to you previously, 1 centimetre, 250 metres. North to the top of the map. Each of the different colours represents different rocks of different ages. Oldest at the bottom, so all these light blues and dark blues are the oldest, and the grey at the top is the youngest. They're all carboniferous in age, but some are sort of lower and some are sort of slightly higher. Denantian and Lemurian. You don't need to worry about those particular names themselves. Okay, so if we zoom in to this particular area and just have a look at the bit that you've got to relate to that particular question, it's this section here. Okay, we've got 2 landslips, which are the sort of black and white stripy bits on there. They occur on the hill, and I'll show you the hill on the geological map in a second. With reference to the evidence from the map, evaluate the likelihood that these are the factors responsible for the landslide. So, are all these factors influencing the landslide? Is it one more than another? Are there some that you can discount based on the map evidence? A technique I tell all my students to do is to put ticks and crosses as you sort of try to work out your answer, and it helps to formulate your response as well. You can always jot down the ideas down the side. Students who do that do the best on these types of questions itself. So the word evaluate strongly influences, weakly influences, no influence. Those are sort of phrases that you can use. Okay, so what I'm going to do is zoom in and have a look at these 2 landslides, and then we'll have a look at what each of these different factors is all about and sort of try to pick out the evidence that we've got on the map itself. Okay, first off, we need to look at the topography. What's the landscape like? Well, we've got our height contours there. The contour lines, you can see really clearly that they're very, very tightly packed together, going from the base of the slope to the top of the slope. So we've got a really steep hillside, and then this is the top of the hill, and it's, well, it's not flat, but it's a lot more gently sloped compared to this section here. So this stuff down there, we're going into sort of a valley, and then we've got 2 reservoirs at the base of the valley itself. The landslide materials is sort of black and white striped area. So this is the northern landslide, the southern landslide. Right, geologically speaking, this stuff here, this sort of like orangey yellow colour, is PG, okay, based on the symbol there, which is Pendle grit. And the yellow stuff, let's see if we can find the code for it. It is just there, which is PDS, which is Pendle sandstone. So if we look at the general vertical column, the sandstone's older than the grit itself. So at the bottom of the slope we've got the oldest, and at the top of the slope up here we've got the youngest, and that sort of fits. So the blue is older than the grey layer itself. Okay, what else? So what rock types are involved on these 2 landslipped areas? Well, we've got the grit at the top, and we've got the Pendle sandstone, and we've actually got in between these 2 is the Boland shales. So the light grey material here is the upper Boland shale, and the dark blue is the lowland bowland shale. So we've got sandstone right at the bottom, we've got shale in the middle, and then at the top we've got grit. So if we think about the permeability, grit is very permeable, it's a very coarse sandstone. We've got shale, which is impermeable. Now, if we think about water, that's going to be an influence on it. Strength of the rock, the sandstone is going to be stronger than the shale. And if the shale gets wet, then the strength of the material will also decrease quite rapidly as well. So could that be a factor? Maybe. What other things have you got to know? Right, it says on the question the dip and the angle of direction of the beds itself. So let's zoom in. I think this area up here is really good at doing it. Right, so these arrows tell you the dip direction and the dip amount. So the grit, where the tip of the arrow is going into the hillside, where the highest bit of the hill is. And it's the same for this part here, dipping into the hillside. So is that likely to move if you've got a hillside which is like that and the layers are tilted into it? Does that make it more or less stable? The other thing to note is if you've got a 10-degree dip and a 9-degree dip, is that steep enough to make the layer unstable? If we can look at the south slip, we've got a dip arrow there, which is 5 going into the hillside. So is the dip direction, the dip amount affecting it? Probably not. We've already discussed the steepness of the slope. We've looked at the height contours. Local groundwater conditions, okay, is there water involved in it? Now what you need to do is not necessarily look at the geological map, you need to look at the underlying OS. So up here we've got some streams which are coming off that particular area, so that could suggest that this is quite wet, it's impermeable, so that may sort of hint towards it. But if we go further to the south, we've got this one here, it says Deep Clough Spring. So we've got water coming out of the ground. So what does that suggest about the groundwater conditions? Is it dry or is it saturated? And the other thing, the last one, is faulting. Now, if I zoom out a little bit, we're going to look for thick black lines with like a little tick mark on. So we're looking for things like this. A thick dashed line with a little crosshair or cross mark on it. If we look in these areas here, there's definitely nothing around the northern landslip, and there doesn't appear to be any mapped faults around the southern landslip that could suggest that that has any influence on it at all. So what have you got to do? Have a look at the map, look at the sort of features up here that I've commented on, and then go through each one of these and comment on whether you think it's going to have an influence, or is it one of those causes for the landslide to take place in that particular area. For each one of those we've got 5 bullet points, so you could say maybe 2 marks each for those 2, and then 3 marks for those in total down here. But you've got to make sure that to evaluate, you've got to say whether it's a strong chance, a weak chance, and no chance whatsoever.